This is the prep packet video for Unit 4, Chapter 9.1. This is the introduction, Part 2, and now we're talking about multiplying with exponents. So multiplication with exponents, you need to pay attention to a couple of things. First of all, for exponents to be multiplied, the bases have to be the same. And just to remind you quickly, the parts of an exponent, this is the base, the big number, and the exponent up here, a to the x, that's also called sometimes it's called a power or a degree, but what we care about right here are the base and the exponent. So here's the base, and then we talk about the exponent. There's the exponent, there's the base. So back to the story. If the bases are the same, you can add the exponents. So here's an example. I am multiplying x squared times x to the third. The answer, combining those and simplifying it, makes x to the 2 plus 3. I'm adding the exponents. 2 plus 3 is 5. You notice nothing happened to the base. So again, if I had 3 to the second times 3 to the fourth, I would have same basis, stays the same. 2 plus 4 is 6, 3 to the sixth. Now, this is very important. If the bases are different, like here, y, oops, I don't want to do that one. Y and x, different bases, you cannot do this. This is against the law. So this is really important. Do not do this. X to the third times y to the third does not equal x times y. Can't do it. This is going to stay exactly as it started, like this. Okay? And again, if you need to see how this works, x to the third is x times x times x times x to the second, x times x. When you're all done, how many have you got? 1, 2, 3 plus 2 is 5. And that's basically why it works. Let's do some practicing in your practice pack. And of course, I know you're going to stop and copy all your notes. So here, I have a to the fourth times a to the third. And as you get working with exponents more and more, you'll say squared and cubed a lot less. So here, a to the fourth, a to the third, are the bases the same? Yes, they are. So I'm going to say a to the 4 plus 3, a to the seventh. Base is the same. Both b's. B to the 2 plus 3 is b to the fifth. This one's a little bit different. This is 5 plus negative 1. And that's the same as 4 because it's 5 minus 1. So this will be m to the fourth. C to the 14th plus 1 gives us c to the 15th. R to the 2 plus 100, I end up with R to the 102. 100 second. Oh, let's see. A to the second, B to the second. That would be, oh, stop. What's wrong with this picture? You have A and you have B. You can't do anything with that. So it's going to stay A to the second, B to the second. Here's a slightly different one. M squared times m to the x. You do this, the same rules apply. This is m to the 2 plus x. So when you write it, it'll look like this. And yes, someday you may have to solve for x when it's in an exponent. What about this last one? I have a to the 1/2 times a to the 1/2. And yes, you can have a fraction as an exponent. That's called a rational exponent. And just so you know, I'm planting a seed here. That's a different way of writing the square root of a when it's 1/2. A to the 1/2 equals a square root of a. So what's 1/2 plus 1/2? It's 1. So that's a to the 1 or just plain a. So go ahead and stop and copy, finish up your notes, and I'll see you in the next video.